application tool you
Um, from my experience, I have from the basic just only the basic driver for that specific network card can change.
Yeah.
They allow to change the MAC address. By right, it should not be right, but there was I experienced before.
Yeah, the only one who can change the MAC address is basically our laptop, Windows or
Yeah.
Linux. This one very rare.
Yeah, I don't think our the standard production do that.
SIG Protect application, what do you call it? SIG Protect application? Dixie 4 or Dixie 5. And then Dixie 4, Dixie 5, you can launch your 61850 configurator. Yeah. And Ethernet, everything is basically out of the Ethernet 2, version 2. This is how it looks like. You have a preamble. This is about six columns. Synchronization, destination MAC address, source MAC address, the type, and the data you're carrying. Here is the detection of the frame. Forward, this is frame check sequence or CRC. So it can detect the frame. These are the frame types. You have unicast 1-to-1 if the destination is known. Of course, your relays, your PC will going to talk towards the destination 1-to-1. Multicast, yes, you can use this one if you're using goose or sample values from one source to many, right? Broadcast is the destination to look at the size of the network, or if the destination is unknown. So it will send out all the traffic. The Ethernet switch is how it manages a so-called forwarding database, or what we call MAC address table. In MAC address table, the switch is smart enough to track where is the learned MAC address, the destination, where it was learned, the destination, and where is the source coming from. So it will be put on a table. Let's say, oh, this switch has four ports, and PCA is connected to port 1, so therefore the switch will have, okay, this is the MAC address of A, PCA is connected to port 1. And as you can see, yeah. So therefore, if the switch receives a data from D and wants to communicate to A, the switch only going to look at the MAC table before it sends out. Let's say, okay, D was coming from port number 4 and wants to communicate to PCA, it's connected to port 1. So the traffic will just gonna be in on port 4, out on port 1. That's what it does, because it's unknown. Otherwise, if it's unknown, it will send out the broadcast to the network. Yeah. And here how it goes. The switch manages the forwarding database or the MAC address table and completes its MAC address table buildup by looking at if the switch is receiving a traffic, let's say that's coming from PCC. There's a series of questions. Is PCC MAC address is in my table? Yes or no? Okay, that's the source. If it's no, okay, put it in the MAC address table, which port it was learned on port number 3, right? And it will going to look for the destination. Yeah, looking for the destination MAC address, and the MAC address saying, okay, PCC wants to talk to PCB. Here, do I have that PCB MAC address in the table? The destination? No. So if it's no, it will send the frame to all the ports except from the port number 3. Because it was received on port number 3, it will not forward the same question to port number 3. It will send out to all the ports except from port number where it came from. So we're going to send out, it will flood it, it will broadcast it, yeah, or it will advertise to all ports, except from where it came from. One fine day, that PCB replies back to the switch and say, okay, PCB, oh, you're connected to port number 2, so it will lock down. And it's going to say, okay, do we have the destination for C? Yes, we have now the destination for C. Which port? C. Which port? Oh,
Part three, right?
Port 3. So therefore, the switch is now going to forward the data unicast to port number 3 instead of broadcast. So that's the switch, how it maintains. And it maintains always with a timer. Each port will have a time for every 5 minutes. We're going to update its MAC address table.
Mhm.
You can modify the timer each time. The default is 300 seconds or 5 minutes. You can modify it lower if you like, but make sure that all the switches in the network are being modified. And then therefore there are going to be some kind of questions for you guys. How is the switch not, you know, handling all this traffic uh, if they want to communicate from a single host and talking to a lot of nodes? We have so-called buffering. In this way, we have data in, data out. First one comes in, the one goes out. So it's always in a series. We don't have a parallel thing. Come first in, first out. In this way, the switch will able to serialize the transmission accordingly, right? And switch will going to receive a communication from D, a frame from C, frame from A that will going to talk to B. You will see that B comes first, so it goes out first, and second and third. How does it go? Because of our frame forwarding, we are always storing forward. Storing forward this kind of method, when we receive the frame from who comes first, we copy the frame to the memory. And this is each of the switch will have a memory. 1 meg, 2 meg, 3 meg, just like a phone or just like a laptop, you have what's the RAM size, memory size. We will copy it from there, and it will check if any of that frames has an error. If the error is there, it detects it, it will drop the frame. Otherwise, if it's no error, it will forward to the specific port based on the MAC address table. Okay. We have a cut through. Cut through is on it's a special type of forwarding method. Instead of copying the whole frame, we look for the destination and off it, off it goes. We're not going to check any errors.
Hmm.
So it's fast, but I don't know if it has an error.
Hmm.
That's a cut through. We use this cut through if you have PRP or HSR.
Why cut through for the PRP and
Because it needs as fast as possible to move the packets to the destination. Cut through means shortcut. I don't want to have I don't want to check my whole frame. I want to make when you read my destination, just pass it over.
Mhm.
That's really fast. So that's why in PRP HSR you have zero latency.
The default of setting is always
Store.
Also, we have to reconfig for
No,
tool, right?
no. You will only going to use cut through when you are having PRP or HSR type of device.
Like in the network, right? We use the PRP, but at the level we have to select that we will use the
By
PRP,
default-
but yeah.
By default, it's PRP.
And for the another switch in the line A, line B network, we not setting, but it
No.
always cut through, right?
Okay, good. Question. In a PRP, we have port A, port B, right? This port A, port B, and even sometimes port C are always the rest are stored forward. In other words, it's converted also. Here in front of you, you have RNA, the first slot. I think this one. This is cut through. This are store forward.
Can be setting stop forward for cut through.
Only for port C. You're just going to select. By default, it's store and forward. But when you say you're going to use it to HSR plus PRP, it's going to change automatically. You will not going to select cut through, but you know it as PRP or HSR. When you select PRP HSR, you're using cut through. Here, you're using what? HSR. It's always cut through. But you know it only as PRP HSR. But that's the at the back of the architecture, it's you're using cut through. You have also RSTP here, right?
Yes.
MRP.
MRP.
RSTP, then if it's RSTP, it's always store and forward.
RSTP is stored forward.
So,
For
MRP.
So in the network that we have the LAN A, LAN B, and the device is connect with the LED box before device, right? At the LED box, we use the cut to go to the network. LAN A, LAN B, right?
Yeah. For this is the red box, right? LAN A, port B, LAN A.
Yeah.
And underneath is something like this is the relay. Connects here. This is store and forward. This is cut through.
Yes, and at the LAN A network, inside we connect via RSTP. So all the setting in the switch in the LAN A.
They're encapsulated in PRP or HSR frame.
Because it's already got the data PRP from here, and then we will forward.
We will forward it. And just make sure that the switches can understand large frame, like 1634, 1636 frame.
Do we need to change setting for the frame size, or do we can use the default? Right?
When you select PRP HSR, it's automatic. Not like before, we have to select how big is the frame. Plus, you have VLAN tags. Plus, you have PTP. You have to add all those.
Like we compare when we try to use some your competitor like Moxa, KLAN, right? Taiwan and Chinese product that the default frame size is small, and then sometimes we cannot use Dixify communicate with relay, and we have to change the
No, for us it's automatic.
But for you is
automatic. Yeah, you don't have to select big or small. Because by default, this and that, they can understand the frame size of. Because we're rookie. Moxa, Kylan, Hirschman, they are intent. Sometimes they are working up in OT, but they sometimes go to industrial side or not utility industrial like factory automation, process automation. So and they have their own so-called proprietary protocols. For us, we don't have. We have a little proprietary protocols, but most of the time we're using industry standard, so that we're open standard, so we are compatible to everyone. Which you will going to see that.
Before so I have one more question about the priority. We talk about that we first come first serve, right? But for 650 goods and SV for we need to priority that is also
in priority for goods sample values and point PTP or point to point. You put VLAN tags. In VLAN tags you can provide priority. By default it's 4.
Can if we did not use VLAN, can we set the priority?
Yes, all of the ports will have default priority and set to 1.
And sorry,
1 or 0.
Because I compare with the other competitor, right? It will have the priority for good and SV. It will detect by protocol, not detect by port. What do you think about that?
Yeah. Now, if you are using VLANs or tagging, depending on you can create VLANs without priority. But if you're depending on your tools, you can create VLANs with priority, or you can set it up with priority. This one you can create by default. It has this port has its priority. It's 1 or 0. You can change it. How it differs. Some of the device does not have capability to understand VLAN and tagging or priority. But when you say, okay, this relays, when it comes here, give them priority. You change that 1 or 0 to 4.
Mhm.
So when it receives,
Understood.
it will have priority. The switch will smart enough to, okay, this one has priority, process it first, you know, before the other zeros. Always highest priority will process first.
Yeah.
Understood.
So I try to compare, right? Almost they already all the products do have the VLAN parity, but parity for boot and with SV protocol it also have in the setting that it feels okay. Right.
Yeah. There's no such things like because in system on 850 it's still evolving. And it's getting mature by all means. Right? It's getting mature. Uh, but again, every company will have their own flavors of system on 850. The basic stuff are there. Yeah. But when you set it, it will not going to set it automatically. It's going to be the designer. The protection engineer will going to set it based on the network engineer and based on the scatter. Most of the time, what I know is that the network is always in VLAN 1 before. Now they're changing it. So they're having a goose on VLAN X, sample values on VLAN Y, and PTP is on VLAN Z, and MMS on VLAN 1. Because MMS is always monitoring in states. Right? Is it up? Is it down? That's what it does. Controls are goose, right? Because it's a one-way communication. It's not a two-way communication. It's how fast you can send the data.